Hello, Rockbridge Pre-Calculus. It's time to multiply matrices by each other. So remember that we talk about matrix sizes in terms of row and then column, so rows by columns. What has to be the same are these interior numbers. So the number of columns in the first matrix and the number of rows in the second matrix have to be the same. So a 2 by 3 matrix and a 3 by 4 matrix can be multiplied. But a 3 by 4 and a 3 by 4 cannot, because these numbers are different. So the inside number has to be the same. So for example, a 2 by 5 could be multiplied by a 5 by 2, because these numbers are the same. But a 2 by 5 and a 2 by 2 could not be. That would not be possible because the interior numbers are different. Now what you may have noticed is that this makes them not commutative. You can do a 3 by 3 multiplied by a 3 by 4, but not a 3 by 4 and a 3 by 3. That's not possible. So they can only go in a certain order. What you do is you take the elements of the first row in the first one, multiply them by the first column in the second one, add the results together, then first row, second column, and onward and onward. And this will make more sense when you see it done. So let's do one together. So the product of an m by blah, blah, blah. You can read that yourself. Example, I don't know what number that used to be. Use these matrices to find, first of all, matrix AB, that is matrix A times matrix B. Well, let's see. Matrix A is a 3 row by 3 column matrix. Matrix B is a 2 by 2 column matrix. These numbers are different, so this is not possible. And we're done. You can't do AB. BC, let's find out. B is a 2 by 2. C is a 2 by 3. These numbers are the same, so this is possible. So here's what we do. Trying to figure out if I need to write it out again, but they are right here. So what we're going to do, we're going to take row 1 and column 1. So I actually literally think of doing this. So I take this and I turn it sideways. So take 4, 2, turn it sideways, multiply it by the 1, 3. So we will do 4 times 1 plus 2 times 3. And that's our first spot. Next, we're going to take again the first row and now the second column. So first row, second column. So that's 4 times 2 plus 2 times 1. And then first row, third column. So 4 times negative 3 plus 2 times 0. So you'll notice this was row 1, column 1, row 1, column 2, row 1, column 3. And now we'll do the second row. So we're going to have negative 2 times 1 plus 3 times 3. So you take these two elements multiplied by these two elements. And then negative 2 times 2 plus 3 times 1. And negative 2 times negative 3 plus 3 times 0. Finally put it all together. 4 plus 6 is 10. 8 plus 2 is 10. Negative 12 plus 0 is negative 12. Negative 2 plus 9 is 7. Negative 4 plus 3 is negative 1. 6 plus 0 is 6. And there you have it. This is B times C. So what goes in row 1, column 1, is row 1 of your first matrix multiplied by column 1 of your second matrix, and the results added together. What goes in row 2, column 3, is row 2 times column 3, and the results added together. So you take the rows of your first matrix, multiply by the columns of your second matrix. That's it. Now, it doesn't mean that that's simple. I think you should get a little more practice with it, but that's the basic concept. Putting matrices in the calculator, all right, I'm going to show this to you, but I want you to know how to do it by hand. So matrices in the calculator, depending on which version of the calculator you may have, it may have a matrix button, or it may be second and then some other button. You get matrix, you have to go to edit, which unfortunately is not the first thing. Pick the matrix you want, tell it how big it is, enter your elements. Quit out of it. To use them, like to add them, you would use edit and enter in the data for like matrix A and then enter in the data for matrix B. Then you would go into your matrix menu again. The first menu is the names menu, so you would select the one you want, like matrix A, and then it would take you out to the main menu. You'd say plus and then matrix B. Last thing is a real-world example of matrix multiplication. This is a 5x3 matrix of touchdowns, field goals, and point after touchdown. And then they give you the points for each and want you to find the result. So you might, doing it by hand, you wouldn't really think about this particularly, but if we're doing it by matrix multiplication, I don't mean by hand, I mean sort of commonsensically, without going into the matrices. Doing it by hand, you know these numbers have to be the same. So what you do is take this 5x3 matrix and multiply it by 3x1 matrix. So it's going to be this times, and then you put the 6 points for a touchdown, 3 points for a field goal, and 1 point for point after touchdown. Do this multiplication, and I'm going to leave finding the result to you. No big surprise, George Blanda is going to be the higher score, but you can find the other scores by actually doing out the math. So you can certainly do matrix multiplication in the calculator. Please also do it by hand so you know how, and I will see you tomorrow.